Hello all, welcome back. This is Christabel Diana from Trinity Software. In this video, let us see the introduction to statistics in Python. Statistics is actually the most important and fundamental component of data science. So if you are interested in learning data science, you can start with statistics. So first of all, what is data science? It refers to dealing with the data. It is the study of data to extract some meaningful insights for business. So in this video, we are going to see statistics with Python. What is statistics? It is a branch of applied mathematics which involves collection, description, analysis, and inference of conclusions from quantitative data. So data can be classified into two types, namely qualitative and quantitative data. Qualitative data means the data which describes the characteristics or qualities, whereas quantitative means it is based on the measurements in the numbers. The example for qualitative is observations, survey responses, etc. And for quantitative, age, height, weight, exam score. So in statistics, we are dealing with quantitative data. There are two major types of statistics: descriptive statistics and inferential statistics. Descriptive statistics describes the characteristics of a data set, whereas inferential statistics means we are making use of the data to predict or draw conclusions about a larger population. So the first basic term is population. Population is the set of elements that you are interested in. So populations are vast, which makes them inappropriate for collecting and analyzing data. So that's why we go for sample, which is a subset of the population, a specific group of elements that you collect from the population is known as the sample. Sample should preserve the essential statistical features of the population up to a satisfactory extent. And the third term is outlier. Outlier means that a data point which differs significantly from the majority of the data taken from a sample or population. Example for an outlier can be a data set which contains the ages of a particular class students. If one age is less than 0, so that is considered as an outlier. It may be a mistake. Okay. To start with, we are going to see descriptive statistics. The major categories are measures of central tendency. We can use mean, median, or mode to describe the center point of the data set. Then measures of position. Examples are percentile, quartile, and decile. Here we can determine the relative position of a data point in a data set. And measures of dispersion or spread determines how the data is spread from the smallest to the largest data, or how the data is far from the center of the overall data distribution. Examples are range, variance, and standard deviation. This is the part 1 of statistics in Python. So in this tutorial, we are going to see only these three measures. So let's start the implementation of statistics in Python. I have opened this Jupyter notebook. So these are the packages to be imported. Before importing, make sure that all these packages are installed in your system: NumPy, Pandas, Statistics, Matplotlib, Seaborn, and SciPy. Okay, execute it. It's executed. Now it starts with a measure of central tendency. It represents the center point or typical values of the data. We need to find out mean, median, and mode. Mean is the average of all values. We all know the formula to find out the average. It is the sum of all values divided by total number of values. Let us take this data set. Data is a list of elements. In order to find out the mean, we can make use of NumPy's mean method. I have already imported NumPy as NP. So NP dot mean method pass this list as an argument data. Okay, which will give you the mean. The problem with the mean is that it is sensitive to outliers. So it may not be suitable for data sets with extreme values. Next, median. When the data is arranged in the ascending order or descending order, the middle number is the median. If in the given data set, the number of values is odd, the middle number can be considered as the median. If the number of values is even, then the median will be the average of two middle values. So it is perfect for data set with outliers. Fine. We can find out the median for this data. Before finding out the median, we can arrange it in the ascending order by calling sorted method. Sorted of data will give you the list in the ascending order. So total number of elements is 11 and the middle element is 36. Okay, np dot median pass data as an argument. So 36 is the median here. So if it contains even elements, you can find out the median np.median of data 1. So it will be average of 36 and 37 is 36.5. So you can make use of the median when your data set contains outliers. And then we have mode. Mode is actually the value which occurs frequently in the data set. If two values have the highest frequency of occurrence, then it is called as bimodal. So to find out the mode, you can make use of SkyPy's stats subpackage. So stats dot mode method pass this data 1 as the argument. If you see in the data 1, 34 is occurring thrice and similarly 38 is also occurring thrice. So if you just call states dot mode of data 1, it will give you mode is equal to the first occurrence 34 and it is present 3 times. Okay. If you want only the value alone, you can just give dot mode. So we'll give you the value alone. And the another method is using statistics. We have imported statistics package also, statistics dot mode of data 1. We got 34. So if you want to find out bimodal, then you can make use of multimode method in statistics. So statistics dot multimode of data 1 will give you a list of all the elements which has the highest frequency of occurrence. Both 34 and 38 have the highest frequency of occurrence. Fine. We can also find out this mean, median and mode using pandas. Classes is a dictionary, the key is the count and value is a list of elements. We are going to create a pandas data frame first and then we will find out mean, median and mode. So data frame df is equal to pandas is imported as pd. So pd dot data frame, convert that dictionary to data frame by passing this dictionary as an argument. Okay, now df dot mean will give you the mean of the count and df dot median, it gives you the median. To find out mode, we cannot directly give df dot mode, we need to add this key also. So df of count dot mode. If you just need the values alone, it give dot values of 0. Will give you the mode, that is 32. 32 is present twice here. Okay, now let's move on to measures of position. Determine the relative position of a particular data to a data set. This measurement can indicate if a data's value is high, low or average. Okay, there are 3 categories: quartiles, deciles and percentiles. Quartiles means we are dividing the data into 4 equal parts. Deciles means that splitting the data set into 10 equal segments, and percentile means dividing it into hundreds. So percentiles is the commonly used measurement in statistics. Percentile differs from percentage. It indicates the value below which a percentage of data falls. That is, the nth percentile of a data set is actually the value at which n percentage of the data is below it. For example, 20th percentile means the value below which 20% of the observations may be found. Let's see the formula to find out this percentile. This is obtained by P by 100 into capital N. P is the percentile, that is 25th percentile or 50th or 75th percentile. And capital N is the number of values in the data set. So you will be getting this ordinal rank of the given value. Let's take this example. It contains a list of ages of people who live in a particular street. Now we need to find out the 75th percentile. It is not in ascending order, so we will just sort it first. Sorted of age. So it is sorted in ascending order. To find out the percentile, we can make use of NumPy's percentile method. It takes 2 arguments. The first argument is the list itself, age, and second argument is the percentile to be found. So if you want to find out 75th percentile, you can pass it as a second argument. So here 42 is the value for 75th percentile. And we can also find out 25th percentile, 50th percentile, 75th percentile in a single method. So using this np.percentile, you can pass the percentiles to be found as a list. So 25, 50, 75. So here 25th percentile is 11.5, 50th is 31 and 75th percentile is 42. 50th percentile is actually the middle value, 31 in this case, right? We can also find out the percentile using statistics. We can store it in a variable called p. Statistics dot quantiles method. We are passing age as the first argument, and the second argument is n is equal to how many divisions you have to make. 100 equal divisions. So n is equal to 100. Now 50th percentile means you can just give p of 49. It starts from p of 0 till p of 99. So p of 49 will give you the 50th percentile. So we got 31 here. Similarly, you can find out other percentiles. So percentiles can be used to detect outliers, that is the data points that are greater than 99 percentile and less than 1 percentile are usually considered as an outlier. Okay. Next, we'll see quartile. It's actually a value that divides an ordered data set into 4 equal parts. So we'll be having 3 values in quartiles, Q1, Q2 and Q3. The second quartile, Q2, is actually the middle value in the data set. So we can find out the quartiles using this statistics.quantiles method itself. Q is equal to statistics.quantiles. Here the data is divided into 4 equal parts. So n is equal to 4. If you just give Q alone, you will get Q1, Q2 and Q3. If you want to find out the second quartile means it should be Q of 1. So using quartiles also you can identify the outliers. That can be done using box plots. We will see that later. The next measurement is decile. The data is divided into 10 equal parts. So we can give d is equal to statistics.quantiles age comma n is equal to 10. Here, in order to find out the middle d of 4, will give you the fifth decile. Okay. The next measurement is z-score. In a particular data set, you want to know how a specific data point compares to the rest of the data. That comparison can be done by telling us the number of standard deviations a particular data point is away from the mean. So the formula to find out the z-score is x minus mu by sigma. X is a particular data point. Mu is the population mean and sigma is the population standard deviation. After calculating z-score using this formula, there are 3 possibilities. You may get a positive or negative value or a 0 value. If it is the positive, z-score means that the data point is above the mean. Negative means it is below the mean. And if it is 0, means the data point is right at the mean. So in that way, you can compare a particular data point with the mean. Okay, we have a data set here. You can calculate the z-score using stats.z-score method. And you can pass this data to as an argument here. So this will give you an array of values. Totally we have 10 elements. So 12, 15, 18, 21 and 24 contains negative values. It means that it is below the mean. And the 6th, 7th and 8th elements are more or less close to the mean. And the last 2 elements, 36 and 39, are above the mean value. Okay. The next category of measure is measures of variation or dispersion. It describes how the data is spread from the smallest to the largest data. Okay. Basic measure in statistics is variance. Variance is the average of squared differences from the mean. It tells how spread out the values are from the mean. So the formula to find out the variance is sigma square is equal to x is the data point, x bar is the mean, x minus x bar the whole square summation divided by n. Standard deviation is just the square root of the variance, that is average distance of values from the mean. And we also have a range, which is a simple measurement. It is actually the difference between the smallest and the largest value of the data. And then we have IQR, that is interquartile range. It is a difference between third quartile and first quartile. And finally, we have this visualization tool known as box plot. Okay, we'll be seeing all these things in detail now. We have a list here with just 5 elements. We can find out the variance and standard deviation of this particular list using NumPy. To find out the variance, we have VAR method. So np.var of weight will give you the variance. You can also make use of variance to compare the variability between 2 data sets. Okay, and we can also find out the standard deviation. So we can give np.std of weight. It's actually the square root of variance. Fine. We can also find out the variance and standard deviation using pandas. So here is a dictionary with 3 key value pairs: name, age, and ratings. Now let's create a data frame. df is equal to pd.dataframe. Pass this dictionary A. Now we can find out the standard deviation for the numeric values, that is for age as well as for rating. So df of age dot find out the variance. Okay. Similarly, you can also find out df of rating dot variance, or if you want to find out the variance for all the numeric values in the data frame, you can just give df dot var and you can pass the argument numeric only. By default it is false. You are setting it to true, so that for both age and rating we have obtained the variance. Similarly, you can find out the standard deviation for both age and rating. df dot standard deviation. We got the standard deviation for both age and rating. Low standard deviation indicates that the data points are close to the mean, and high standard deviation means that data points are spread very far apart. Okay. Then the range is actually the simplest measure of variation, and it is sensitive to outliers. Extreme values can heavily influence the range, which can mislead the data analysis. Let us see how to find out the range now. We have this list of scores. You can make use of NumPy's max and min method to find out the range. So np dot max of scores minus np dot min of scores will give you the max minus minimum, and scores vary by 51 points between the highest and the lowest scores. Okay, we can also make use of another method in NumPy, np dot ptp, pass this scores to find out the range. It will give you the range. Okay, then the most important statistical measure is interquartile range. It is actually the difference between third quartile and the first quartile, that is Q3 minus Q1 is the formula. It's used as a measure of statistical dispersion, and it specifically focuses on the middle 50% of the data. The another way of finding out this Q1, Q2 and Q3 is using percentiles. The 25th percentile is same as the first quartile, 50th percentile is same as the second quartile, and 75th percentile is same as the third quartile. So we can find out percentiles and we can find out IQR. We can make use of this same data scores. It is not arranged in ascending order. Let us arrange it sorted of scores. Okay. Now Q1 is obtained by np dot percentile. The first argument is the data set, scores, comma, and which percentile you want to find out, 25th percentile. Similarly, you can find out Q3. Q3 is np dot percentile, scores, comma, 75. Q3 minus Q1 will give you the IQR. So the IQR is 19 in this case. There are various methods to find out IQR. Okay, using stats package, that is stats.IQR of scores will give you the same value, 19. Okay, the other method is using pandas data frame quantile method. Create the data frame first, that is pandas dot data frame scores list as an argument. Now using df dot quantile method, find out the Q1 0.25. So this is Q1, Q3, that is 0.75. It will give Q1 and Q3. So from this we need to find df dot quantile 0.75 minus df dot quantile 0.25 whole bracket. We need only the values from this data frame. So you can just give dot values of 0. Will give you the IQR. Okay, and IQR is also resistant to outliers. It focuses on the middle portion of the data, making it less sensitive to extreme values than the range. Okay, the box plot is a graphical representation of the data that visually displays the distribution, central tendency, and spread of the dataset. So this box plot also highlights the outliers and provides a quick overview of the dataset's range and IQR. There are 3 components in box plot. First component is the box, which represents the IQR. There will be a line inside the box which shows the median, and whiskers extend from the box to the smallest and largest values within 1.5 times the IQR from Q1 and Q3, and outlier will be outside the whiskers, that will be plotted as individual dots. So we'll see the components of the box plot with an example. Here's a list of exam scores. Now we need to plot box plot. We will make use of matplotlib plot dot box plot. So the first argument is list itself, exam scores, and there is an optional second argument. By default the box will be in vertical. I don't want a vertical box, we'll make it as a horizontal one. So I'm setting vertical is equal to false. Then set the title for the box plot, that is box plot of scores. Also we can set the x label plot dot x label here scores, and finally call plot dot show method. Execute it. So we got the box. First two components are seen in the box. The box represents the IQR showing the range between Q1 and Q3. The line inside the box marks the median. So median value is exactly 90. Then we have this whiskers. Whiskers extend from the box to the smallest and the largest values within 1.5 times the IQR from Q1 and Q3. In this box plot, there is no outlier. So you can change the data so that we can see the outlier. So let me give a negative value in the exam scores, which is an outlier. So we can see that in the form of a dot here. Okay, fine. These are the most important measures in descriptive statistics. This is just the part 1 of statistics in Python. So we'll be seeing the continuation of this in part 2 tutorial. Thanks for watching. If you like this video, kindly share and subscribe.